I'm Alex. I'm joined here with Husain, my colleague at Microsoft, and he built a very cool demo with the semantic kernel. We want to check it out, see what it is, and hopefully get inspired by this sort of thing. So, Husain, I'll hand it to you. If you want to give a quick intro about who you are, what you're doing, and then maybe kind of lead into what you built.
Hi, I'm Husain. I'm a software engineer for Microsoft To Do. I work on the back end. So I was exploring on how folks use LLMs and what kind of applications can be built on LLMs. So I've been going through lots of videos and sort of documentation online, trying to learn about LangChain, about how prompt engineering works. And during this build, I got a really good look into semantic kernel. I watched the video of Sam Schilassi talking about how semantic kernel was built, what are the principles, and it got me excited to try it out. So I was just browsing GitHub and Twitter and seeing what all things folks have done, and I saw that no one had really built a good Wordle solver. So I was like, this is a good weekend project. We should do it. And I picked semantic kernel to help me with building the prompt, adding context variables in it, and doing state management. And I wanted to basically explore how well GPT would perform if it was given the task to solve Wordle. Wordle, as you know, is a very popular five-letter game where you have to guess the word of the day, and you have 6 attempts to do, and there is like a color scheme thing which happens based on whatever guess you do, which says that whether your letter is correct, green or yellow. So I built my solution using Python. It's a single Python script. It looks at your screen and automates clicks and enters the word. And basically, what we do is we give the state of the Wordle page to GPT, to the LLM, in a format where it can understand it better, and then it gives a guess word. We enter that, and then that kind of loop goes on until it either solves or it doesn't. Results, I was pretty surprised that it was able to solve some of the days. So, but some days it doesn't land on the right answer because yeah, it's still a tricky game. So should I go through the code or should I show the demo
How about let's see a
working?
demo first, and then we can walk through the code
Yeah.
afterwards.
Okay, I'll share the screen. Hi, so I'm going to demo my Wordle solver script, which was built using semantic kernel. Wordle is a 5-letter word guessing game where you have 6 attempts to guess the right word of the day. The word changes every day. And whenever you get a letter right in the right position, it turns green. Or if you guess a word which has a letter which is in the secret word but is not in the right position, that will be yellow. And if a letter is not in the guess word, it's gray. So let's see how my script attempts to solve Wordle. So first, it will try to find the Wordle game board on my screen. The first word which it guesses is hard-coded. Now you see it keeps the T in the right position because T was green. It's giving really good uh, attempts. 3 letters in the final word. I think it knows you, but yeah, it couldn't solve it, unfortunately. Yeah, sometimes GPT-4 solves the game, sometimes it doesn't, but here it tries to solve it and it gives good attempts like a human would. Yeah, that's all. Yeah. So the Wordle solver agent is a one Python file that solves the whole Wordle, that attempts to solve Wordle like a human. We have a single prompt made over here, and I primarily use Semantic Kernel as a prompt templating engine. I'm not using its planner features, or I'm not even leveraging using different skills or something. But just using semantic kernel as a prompt templating framework is really helpful because I really like how we can persist variables in the prompt and change it according to the flow. Because this agent has to produce several guess words, like six guess words in the maximum. So the prompt won't change that much. Like the rules will be there in the prompt stating that Wordle is a five-letter guessing game. And I also talk about some of the rules over here in the starting that if it's a green position, then that means the letter is in the correct position. Otherwise, it's an invalid letter or it's a correct letter but in the wrong position. So I've made like I've converted the game into its text form. So I represent the guess word as it is, and the result observation in the form of letters where X is invalid, G means green, yeah, Y means yellow. So how this helps is we can give the prompt the entire history of whatever it's done up till now. So all of its previous attempts as well as their result. So it can then make better judgments to include the letters that are valid, exclude the letters that are invalid, and give better guesses. So that comes in this history context variable over here. I also maintain another context variable saying invalid letters. So I keep a collection of all of the letters that are xed, and this helps it to avoid using those letters in whatever guess words it's trying. I've also written that over here as a rule, do not use invalid letters in the guess word. And I've also asked it to make sure that the guess word is a valid English word because it wasn't doing that earlier. Some words were out of English and Wordle then rejects those. And then finally, we just ask it to give us the guess word. So behind the scenes, I'm using GPT-4, using the OpenAI, my personal OpenAI key. Here I declare the context variables. Um, I'm also like, oh yeah, I forgot to mention this, but I'm also maintaining a valid letters with position word. So this word is basically whenever we find a green word, for example, E over here, then this word will be dash 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 E dash. So this will help the LLM keep track that what letters I should not move at all, and my guess should always have that letter in that position. And this actually helped its reasoning capabilities a lot because before this, it was just neglecting the position of whatever letter it was, which was green, and it was trying different permutations and combinations of not keeping that letter over there. It was treating it as yellow. So giving these sorts of representations, I think, helps make GPT's work easier, and it actually improved the accuracy a lot. Here are some basically helper functions which helps. So I'm using PyAuto GUI, which simulates the clicks. It finds the location of the Wordle page on the screen, and we and yeah, simulates entering the word. We also take a screenshot of the board and try to get the pixels of all of the boxes. We these Since these pixels are hard coded, we can perfectly get the result of the observation, like is this a yellow, is this a green, or is this invalid. uh, this is basically when we get the guess word from the LLM. So before guessing the word, I keep track of what was the last guess and the guess result. And based on that, I update those context variables. So here I'm updating the history with the last guess and the guess result. Here I'm sorting and updating those valid letters and invalid letters, context variables. And I'm generating that valid letter word, which I described earlier. Finally, we just invoke using this semantic kernel function. We just call the LLM, and whatever result we get, we just use it. This is the main function. So I start with a very good starting word like this. I think I found online is one of the best starting words for Wordle. And yeah, it's just a loop of observing the screen, getting the word from the LLM, entering the word, uh, keep track of the previous word, wait for 3 seconds, and keep doing that. And we stop whenever we get the result observation as green, all green. So then Wordle solver wins. Or if we reach till here and we still haven't gotten all green, then Wordle solver basically fails. That's the
Very
code.
cool. Yeah, very cool, very cool. Uh, so you mentioned that you're using GPT-4. Did you play around using some of the other models like 3.5 Turbo? Uh, would it still work, or do you need something as powerful as GPT-4 to handle this?
Yeah, I tried 3.5 Turbo and it had a hard time again giving only English words as attempts. And it also had a hard time tracking uh, some of the letters which were green. So it even though it got few greens in its previous attempts, the next attempt had words which were completely not using any of those green ones. So I think GPT-4 has a much better performance. I've tried the same prompt on both
Mm,
for three,
mhm.
3.5 and 4.
Yeah. Yeah, just from looking at this, it seems like a lot of thought was put into the actual prompt construction. What would you say, I guess what percentage of the time did you spend actually writing this prompt, testing it out, iterating on that?
Yeah, I think yeah, half of the time was spent getting the GUI automation in place properly. And yeah, rest 50% of the time was spent on iterating the prompts. There were, I think, three versions of the prompts. I think, yeah, I can show them over here.
Mm,
There were three versions of the prompts. I initially started with not giving it the history, and I thought that if I would just maintain uh, like sets of valid and invalid letters, it would help GPT. But then we lose the positional information that which letter was valid in which position. So, and there were also like few letters that um, yeah, so basically, yeah, the positional value was not given over here. So then I updated this prompt with having the history and the valid letters with position representation, which I discussed. And I even in this, it was giving, um, it was sometimes using invalid letters, like letters that were already grayed out, but it was still using it. So then my final version is the version which I've posted like over here, that where I also have keep track of the invalid letters.
yeah.
So it
So
took
if you
three
were to
iterations. Oh,
yeah, so if you were to abstract this, what sort of lessons would you take away from prompt engineering? Like how to, create a good prompt to do what you wanted to do?
yeah, we need to make sure we give we make GPT's life easier. Like we make the LLM's job much easier. So I think having representations like the valid letters with positions, having such sorts of representations will help in its reasoning ability. And that was pretty much my number one takeaway, that having very good representations that will make the LLM's life easier.
Yeah, yeah. I mean, I view it as like if you're especially in a game scenario, right? There's I'm sure there's forums of people outlining their strategies for how to solve a game, like this one. And if you even just maybe copy paste those strategies into the prompt, maybe that might be like very helpful. But overall, my own experience certainly has been the more you give to GPT, obviously you're paying for it in on the token side, but the more you give to it, often the better it will be, the better it will perform. If you're playing a game, just outline the rules, give examples of the gameplay, kind of like what you showed here, and then yeah, kind of also include the sort of domain knowledge of like, oh, these are some like strategies or tips for how other people have like solved this game normally. So
Yep,
cool,
agree on all of those.
cool. All right. So I guess last set of like fun questions is um I guess where do you see semantic kernel, GPT, these sort of large language models fitting into either the sort of projects you want to do going forward or even like your current work?
Like one of the things which I'm excited like about using these LLMs is that I want to see how it does tasks. So personally, for my personal projects, why I chose the game of Wordle is that I've seen AI projects like Deep Blue and AlphaGo play video games. So these are all reinforcement learning trained artificial intelligence agents that were competing against humans. So I wanted to see how GPT would perform on text-based games. I also tried to play crossword with it, and it was performing really well. Although I have to still work on how to best represent the crossword puzzle in a textual format to it. But it's just I'm very curious to see how these reasoning. I want to see the reasoning capabilities of these LLMs and how well they can play games. Um, so this was just one example of how I tested GPT on playing a word game. Uh, future In the future, I'll maybe try to see if similar word games or textual representations of existing puzzles, and I want to see their performance on that. Uh, I'm also really excited if GPT-4 comes out with the image input as well. So then it would be image and text. And my moonshot project is to actually make GPT play Portal, which is a really good single player puzzle game, and which actually teaches you like the initial levels teaches you the basic rules of the game. So I want to see, will GPT learn those basic rules of the game and progress forward level by level to finally complete the game. So once image input comes, that will be a really interesting time.
Yeah, for sure. For sure. Okay, very last question from my side is outside of Wordle, what's your favorite game that you're playing right now?
I'm actually playing Zelda Tears of the Kingdom right now, and it's super great. Like the sense of exploration and the kinds of puzzles which you get even in the game are really interesting. This game is very creative, the latest Zelda, where you can build small contraptions by attaching basically anything and powering uh, like wheels with rockets and stuff. So it's a it's creative and puzzle solving in the same way. And you have a huge sandbox to sink hours into it. So I love that.
Yeah, yeah, I've been playing it myself as well. It's a time sink, but I you end up spending a lot more time than you probably would have set out to do playing it because there's just so many permutations, so many things you could do. So
Yeah, definitely. Just
yeah,
finished the Wind Kingdom and almost done with the water. Kingdom area right now. Let's see.
I just got my parachute, so I'm not even that far.
Oh, you have a huge time
I have
sink
a,
waiting
I
for
have
you.
a, yes, I have a long way to go. That's right. Cool. Well, thank you for the time, Hussein. Really appreciate it. And yeah, certainly look forward to any future hacks that you build with the semantic kernel or anything with large language models. So yeah, thank you for the time. And
Yeah, yeah, yeah.
with
Love
that,
talking to you.